Hello and welcome to the next session of machine learning course. Today I'm going to discuss about another type of deep learning which called long short-term memory network (LSTM). In the previous lecture we talked about CNN as a classification method. Now in this lecture we would like to talk about a deep learning method for regression. Here we introduce Lstm and we will implement it in Python. So let's have a look to introduction of deep learning and RNN. So RNN were created because there were a few issues in the feed-forward neural network. What is RNN? Recurrent neural network. So and why we have to introduce RNN? What was the problem with the previous deep learning? As I mentioned to you, there were few issues in the feed-forward neural network. Means that in feed-forward neural network, they cannot handle sequential data. Also, consider only the current input, cannot memorize previous input. So the solution to this issue is to introduce recurrent neural network, RNN. RNN can handle sequential data, accepting the current input data and previously received inputs. RNN can memorize previous inputs due to their internal memory. So RNN also works on the principle of saving the outputs of a particular layers and feeding this back to the input in order to predict the output of the layer. Below here is how you can convert a feed-forward neural network into a recurrent neural network. Here is simple RNN. If you look at the feed-forward neural network, you had the input layer, hidden layers, and output layers. Then for converting to recurrent neural network, they have the simple algorithm or simple diagram that you can see here is a B and A and C. They have the loop for the memory, and we will discuss about this issue in the next slide. As you can see in this figure, the node in different layer of neural network. Here you see the nodes in different layer of neural networks are compressed to form a single layer of recurrent neural network. You see here ABC that we mentioned here. Also ABC are the parameter of neural networks. Here is another view of this figure. X is input layer, H is hidden layer, and Y is output layer. So A and B and C are the parameters. We call fully connected neural networks or fully connected recurrent neural networks. So if you look at another picture, the output at any given time is fetched back to the network to improve on the output. Here X, as you can see here, X is the input layer and H is the hidden layer and Y is the output layer. A and B and C are the network parameters used to improve the output of the model. At any given time t, the current input is a combination of input at xt and xt minus 1. You see here we have xt and xt minus 1. The output at any given time is fetched back to the network to improve the output. The figure here, we got fully connected RNN, shows exactly what I described to you. Now it's time to focus on how does RNN works. In RNN, the information cycle through a loop to the middle hidden layer. The input layer X takes in the input to the neural networks and processes it and passes it onto the middle layer. If you see this procedure, the input layer X takes it and the input to the neural network. The middle layer H can consist of multiple hidden layers. See here, each with its own activation function and weights and biases. If you have a neural network where the various parameters of different hidden layers are not affected by the previous layer, the neural network does not have memory, for example. Then you can use a recurrent neural network. So we have the different type of RNN. One-to-one, here. One-to-many, many-to-one, and multiple inputs to multiple outputs, many-to-many. For example, in terms of one-to-many, it means that we have the single input, multiple outputs. It's very good for time series. Single input, single output. Multiple inputs, multiple outputs. So let's have a look. What does it mean? In one-to-one, this type of neural network is known as the vanilla neural network. It is used for general machine learning problem, which has a single input and single output. One-to-many. This type of neural network has a single input and multiple output. An example of this is the image caption. And also many-to-one RNN. This RNN takes a sequence of inputs and generates a single output. Sentiment analysis is a good example of this kind of neural networks, where a given sentence can be classified as expressing positive or negative sentiments. Many-to-many. This RNN takes a sequence of inputs and generates a sequence of output. Machine translation is one of the examples. RNN enables you to model time-dependent and sequential data problems, such as a stock market prediction, machine translation, and text generation. So it's time to go to another section which is called Lstm, long short-term memory networks. Lstm are a special kind of RNN capable of learning long-term dependencies by remembering information for long period is the default behavior. The expression long short term refers to the fact that LSTM is a model for the short term memory, which can last for a long period of time. And LSTM is well suited to classify, process, and predict time series given time lags of unknown size and duration between important events. So, as I mentioned to you, all RNN in the form of a chain of repeating modules of a neural networks. In standard RNNs, this repeating module will have a very simple structure, such as a single tangent layer. If you look at this figure, it's clear how does it works. Lstm also have a chain-like structure, but the repeating module is a bit different structure. Instead of having a single neural network, 4 interacting layers are communicating extraordinarily. So it's time to describe how does Lstm works. Lstm works in a 3-step process. Step 1, decide how much past data it should remember. The sigmoid function determines this. It takes at the previous state, for example, ht minus 1 along with the current input xt and compute the function. So here, this is the first step, as I mentioned to you. This step in the Lstm is to decide which information should be omitted from the cell in that particular time step. For example, in this formula, you have ft, is it forget gate, and sigmoid function here. wf, the weights, ht minus 1, output from the previous step, xt, input, bf, bias for forget gate. And let's go to step 2. Step 2 is that they decide how much this unit adds to the current state. In the second layer, there are 2 parts. One is the sigmoid function and the other is tangent function. In the sigmoid function, it decides which value to let true, for example 0 or 1. Tangent function gives weight gate to the value which are passed, deciding their level of importance from the -1 to 1. In step 2, if you look at the formula, as I mentioned to you, we have the sigmoid function and tangent function, and from here we have the it, index t is it input gate, and we have sigmoid function, wi is weights, h index t minus 1 is the output from the previous step, xt is input, and bi is a bias for input gate. So the third step is to decide what part of the current cell state makes it to the output. The third step is to decide what the output will be. First, we run a sigmoid layer which decide what part of the cell state make it to the output. Then we put the cell states through tangent to push the values to between -1 and 1 and multiply it by the output of the sigmoid gate. Here is the third step is to decide. Here's the formula, and OT is the output gate. Is it sigmoid function, and W index 0 is a weight. HT minus 1 is the output from the previous step. XT is input. BI is bias for input gate, and CT is cell gates. So here is the total description of RNN and Lstm. Now in the next session I'm going to describe how to implement Lstm in Python with real example. Now it's time to focus on Lstm in Python. First, we import some library and package such as NumPy and Pandas. Also, we import Lstm here from class.layers import and from TensorFlow package. At first, we fix random seed equal 42 to get the same result for every running. So again, I can repeat it. This is the fixed random seed for reproducibility to get the same result for every running. So after you import the library app module, it's time to import the data. The problem we are going to look at this post is the international airline passenger prediction problem. This is a problem where given a year and months, and the task is to predict the number of international airline passengers in the units of 1000. The data ranges from January 1949 to December 1960, or 12 years, with 144 observations. This is discussion about data set. Here we load the data and print it. pd.read.csv, and you can print it and show the head of the data. They will show you the 5 records of data, and we are not interested in the data column given that each observation is separated by the same interval of 1 month. Therefore, when we load the data, we can exclude the first column. Okay. The code to load and plot the data set is listed below. This is the loading the data again, and we plot the data set based on this dataset dot plot. So here is the way that I wanted to show you the visualization of dataset. After you import the data, it's time to normalize the data. So Lstm are sensitive to the scale of the input data, especially when the sigmoid or default or tangent activation function are used. It can be a good practice to rescale the data to the range of 0 to 1, also called normalization. We can easily normalize the dataset using the min-max scalar preprocessing class from the scikit-learn library. So in this cell, I just put a scalar equal to min-max scalar. This is one of the normalization techniques from the range of 0 to 1, and we fit it, transform it to the dataset. So after you run, it's time to split the data. For evaluation the model, we need to unseen data for the test phase. So with time series data, the sequence of value is important. A simple method that we can use is to split the ordered dataset into train and test dataset. The code below calculates the index of the split point and separates the data into the training dataset with 70% of the observation that can be used to train our model, leaving the remaining of 30% for testing the model. Here we already divided 70% for the training, and the rest for the length of the data minus training size is a rest, means 30% for test size. So after you run, you can see that from this data 100 is for training and 44 for the tests. So after splitting the data set into training and testing, now it's time to give you one sample or example. Create a data set. In this example, we want to predict the number of passengers for t plus 1 by using the number of passengers in t. Means that the current time, and they predict the number of passengers in time 2. Means that 1 day ahead. To this aim, we have to create data set as we want. This function create data set for the next step. The function takes 2 arguments, the data set, which is numpy array, that we want to convert into a data set. And the look back, which is the number of previous time step to use as an input variable to predict the next time period. In this case, defaulted to 1. So this default will create a data set where X is the number of passengers at the given time t, and Y is the number of passengers at the next time t plus 1. It can be configured, and we will by constructing a differently shaped data set in next section. The Lstm network expects the input data, for example X, to be provided with a specific array structure in the form of, for example, sample, time step, and feature. So we reshaped train and test data for Lstm input. Currently, our data is in the form sample feature, and we are framing the problem as one time step for each sample. We can transform the prepared train and test input data into the expected structure using numpy.reshape as follows. So after you reshape input to be sample, time step, and features, it's time to create and fit the Lstm model. We call create Lstm model. Like the previous session, you create a CNN, you create ANN. Now it's time to create an Lstm model. The network has a visible layer with 1 input, a hidden layer with 4 Lstm blocks or neurons, and an output layer that makes a single value prediction. The default sigmoid activation function is used for the Lstm block. Here you see the network is trained for 100 epoch, and a batch size of 1 is used. This is already discussed in CNN or other deep learning model that we talk about. This is the creation model for deep learning. After you summarize the model, you can find that the Lstm, the layer, the output shape and parameter. Layer is Lstm, and the output shape is 4, and dense here also the layer in the layer dense we have 1 output. So the total parameter is 101, and trainable parameter is 101, and non-trainable parameter is 0. Now it's time to run the model. As you look at this section, the model compile, you already provided the mean square error, MSE, and your optimization is Adam, and model fit, as I mentioned, the default sigmoid activation function is used for this Lstm, and the network is trained for 100 epoch and a batch size of 1. Also here we have the epoch is started until the end. They will reach to the last function that you needed. So the next step is to predict our model. So in order to predict our model, once the model is fit, we can estimate the performance of the model on the train and test dataset. This will give us a point of comparison for new model. So that we invert the prediction before calculation error score to ensure that the performance is reported in the same unit as the original data. Means that thousands of passengers per month. So we use the scalar. You can see here for the invert prediction, you use the scalar inverse transform function. Also, we use RMSE to calculate for training and test data and plot the prediction data in real output. So, as I mentioned to you, we also calculate the RMSE for training and the test data, calculate the metrics for the train and test data, and plot the prediction in comparison with real output. Here is the result from the training score. RMSE is 22 and the test score is RMSE is 53.40. So after you get the result, it's time to visualize the data. So plot baseline and prediction. So you have the test data, you have the test predict. So it's time to plot it and see what the orange color said in comparison with the blue color. So it seems it's very close together for prediction. So Lstm for international airline passenger problem with window regression framing, many to one. So we can also phrase the problem so that multiple or recent time step can be used to make the prediction for the next time step. This is called a window or many to one. And the size of the window is a parameter that can be tuned for each problem. For example, given the current time t, we want to predict the value at the next time in the sequence t plus 1. We can use the current time t as well as the two prior times t minus 1 and t minus 2 as input variable. When phrases as a regression problem, the input variables are t minus 2, t minus 1, and t. And the output variable is t plus 1. The create database function, here we load the database and we create the database. And the create dataset function we created in the previous sections allow us to create this formulation of the time series problem by increasing the look back argument from 1 to 3. So we can rerun the example in the previous section with the larger window size. So here we already put the window size and you can see that the result will appear. We can see the error was increased slightly compared to that of the previous section. The window size and the network architecture were not tuned. This is just a demonstration of how to frame a prediction problem. I hope you enjoy this section and try to apply our example, and we have more example in next session.